Imagine standing at the edge of everything you have ever known, not at the rim of a canyon, not at the shore of an ocean, but at the boundary of human understanding itself, where the last cartographers of the ancient world once wrote their warnings, where the known dissolved into myth, and where the darkness beyond was not empty, but infinite. Now imagine that darkness answer back. Somewhere out there in the cold and silence between stars, a world turns. It has turned for billions of years. Long before the first human I ever looked upward and wondered. It has weather. It has seasons. It has a sun that rises and sets over mountains we have never named. It has oceans, perhaps, or the ghost of oceans, or something stranger than either. We found it. After centuries of reaching, after Copernicus rewrote the heavens and Galileo was punished for telling the truth, after generations of astronomers pressed their eyes against brass and glass and dreamed of worlds beyond worlds, after all of it, we finally found something that made us stop breathing. A planet orbiting another star. The right size, the right distance, the right temperature. A world that, from the outside, looks the way Earth must have looked to some imagined stranger passing through our solar system 4 billion years ago. We called it, quietly at first, a second Earth. And then the questions began. There is a particular kind of silence that falls over a room full of scientists when something impossible becomes real. It is not the silence of emptiness. It is the silence of too many thoughts arriving at once. The silence of a world shifting beneath your feet while you're trying to stand still. That silence fell in 2016 when a team of astronomers announced the discovery of Proxima Centauri b, a planet orbiting Proxima Centauri, the closest star to our own sun, a mere 4 light years away. In cosmic terms, a neighbor. In human terms, 25 trillion miles of frozen nothing. But it was there, and it was, by every preliminary measure, possibly habitable. The word habitable carries more weight than almost any other word in the language of science. It does not mean comfortable. It does not mean welcoming. It means only this, that the conditions for life as we understand it might exist, that liquid water could theoretically pool on a surface, that chemistry could proceed, that something in some form could persist. It was enough. It was more than enough. It was everything. Newspapers ran headlines that felt torn from science fiction. Social media lit up with the brightness of collective wonder. For a moment, brief and beautiful and fragile, humanity looked up together and felt small in the best possible way. But the scientists in those quiet rooms knew something the headlines did not say. They knew that finding a second Earth is only the beginning of a question, so vast it rewrites every answer that came before it. Could we actually breathe there? To understand why that question matters, why it reaches into something deeper than science, deeper than space travel, deeper even in survival, you must first understand what air actually is. Not the word, not the concept, the thing itself. Close your eyes for a moment and breathe. Feel that. The slow expansion of your chest, the quiet rush of something entering you, something invisible and ancient and absolutely necessary. You are breathing an atmosphere that took 3 billion years to build. 3 billion years of geology and biology locked in an invisible embrace, exhaling oxygen into void above a cooling planet. Building, molecule by molecule, the thin shell of gas that makes your life possible. That atmosphere is not accidental. It is the result of the most extraordinary chain of events in the history of the solar system. Volcanic eruptions releasing gases from the deep interior of the planet. Primitive microorganisms, cyanobacteria, ancient beyond imagining, beginning to photosynthesize, pumping oxygen into an atmosphere that had never known it. A catastrophe called the Great Oxidation Event 2.5 billion years ago, when oxygen became so abundant it poisoned most of the life then living, transforming the planet utterly, clearing the way for everything that came after, including us. We are the inheritors of a catastrophe we were not there to witness. We breathe the aftermath of a mass extinction. Every breath you take is a gift from organisms that died before the first animal swam in any ocean. Now stand on Proxima Centauri b. Stand there, in your mind, with your human lungs and your human chemistry, and your inherited 3 billion year atmosphere, and ask, what is the air made of here? The silence that follows is not comfortable. Proxima Centauri b exists in what astronomers call the habitable zone, that narrow band of orbital distance from a star where temperatures could allow liquid water on a planetary surface. Not too close to boil, not too far to freeze. The Goldilocks zone, the just right distance. Earth lives there. Proxima b lives there too. But the star it orbits is nothing like our sun. Proxima Centauri is a red dwarf, a small, dim, ancient star burning at a fraction of our sun's temperature and brightness. It is old in the way that makes our own sun seem young. It has burned quietly for billions of years, and it will burn for billions more long after our sun is swollen and consumed the inner planets of the solar system. In some ways, a red dwarf sounds ideal, stable, long-lived, patient, but red dwarfs carry a secret. They are violent in ways that cannot be seen from a distance. They are prone to stellar flares, eruptions of radiation and charged particles that dwarf anything our sun has ever produced, measured against the scale of the planet in their orbit. Proxima Centauri has been observed producing flares that would strip the atmosphere from an unprotected world, bombarding its surface with ultraviolet radiation and X-rays at levels that would tear apart the molecular bonds of organic chemistry, that would turn the surface of a planet from a cradle into an oven. And Proxima Centauri orbits close, very close. It must to be warm enough, but that closeness means it lives inside the kill radius of those flares, bathed in radiation in ways that no life as we understand it could easily survive. There is more. Because Proxima b orbits so close to its star, it is likely tidally locked. The same face always turned toward the sun, a permanent noon on one side, a permanent midnight on the other, a world of eternal fire on one hemisphere and eternal cold on the other. The boundary between them, the Terminator line, would be a strip of perpetual twilight, a band of amber dusk circling the planet like a scar. And here is where the air becomes the most important question of all. If there's an atmosphere on Proxima Centauri b, if, against the violence of its star, against the tidal forces, against the radiation, if there is still a shell of gas clinging to this world, then everything changes. An atmosphere could redistribute heat between the day side and the night side. It could carry warmth from the fire into the cold. It could create wind, vast, howling planetary winds unlike anything Earth has ever known. Winds that roar around the Terminator line, that carry moisture and temperature and the faint possibility of equilibrium across an alien sky. If there's an atmosphere, that word, if, is the weight that breaks the sentence. We do not yet know. We cannot yet know. The technology required to analyze the atmosphere of a planet 4 light years away does not yet exist in the form we need it. We can infer, we can model, we can run the mathematics of atmospheric science through our computers and generate probable worlds. Worlds that might be, worlds that could be, worlds that we have built from logic and physics and desperate hope. But we have not seen the sky of Proxima Centauri b. We have not measured its air. And this is where the story becomes something other than a scientific puzzle. This is where it becomes something human. Because humanity has always moved toward the horizon it cannot yet see. We have always walked toward the edge of the map. We have always boarded ships for waters no vessel had crossed, climbed mountains the gods were said to own, descended into deep where light did not follow. Every time, we asked the same question before we moved. Is it survivable? And every time, the answer was partial, incomplete, just enough to justify the next step forward. The explorers who crossed the Pacific did not know what waited on the other side. The mountaineers who first laid eyes on Everest did not know if human lungs could function at that altitude, and some of them died proving that they could not, at least not without preparation, without equipment, without an understanding of what the body needs when the air thins to almost nothing above 8,000 meters. We have always tested the boundary between ourselves and death. We have always asked the atmosphere to admit us. Sometimes it has. Sometimes it has not. There's a concept in atmospheric science called the atmospheric escape velocity problem. The brutal arithmetic of whether a planet is massive enough and its star calm enough to hold on to its air over geological time. Earth holds an atmosphere because it is mass enough to keep it, a magnetic field generated by its spinning molten iron core to deflect the worst of the solar wind, and a star, our sun, that is, by the standards of red dwarfs, relatively gentle in its violence. Mars once had an atmosphere. The evidence is written in its ancient riverbeds, in its dried lake beds, in the chemical memory of its rocks. Mars was once warm. Mars was once wet. Mars was once, perhaps, a world where something could have breathed. And then Mars lost its magnetic field, and its atmosphere bled away into space, molecule by molecule, stripped by the solar wind over hundreds of millions of years. And what remained was a thin ghost of air, 95% carbon dioxide, pressure so low that liquid water cannot exist on the surface, a world that remembers being something else and is no longer that thing. Mars is the warning written in red. Now look again at Proxima Centauri b, a world orbiting a violent star, a world that may or may not generate a magnetic field, a world whose atmosphere, if it ever had one, has been under bombardment from stellar flares for billions of years. The models disagree. Some suggest that a thick enough initial atmosphere, rich in heavy molecules, could survive the flares, that the planet could hold enough air to maintain pressure, to scatter light, to cycle water between surface and sky, that the terminator zone could be not hospitable exactly, but not lethal, that life, in the extremophile traditions of Earth's most resilient organisms, could find a way to persist in cracks and depths and thermal vents, away from the surface's radiation, sheltered by rock and water and time. Other models suggest the opposite, that the stellar flares would have stripped the atmosphere completely within the first billion years, that the surface of Proxima Centauri b is a dead world, airless, irradiated, silent in the way only dead things are silent, that what we have found is not a second Earth, but a second Mars. A beautiful idea, a heartbreaking reality. We do not know which world it is, and the not knowing is its own kind of vertigo. But here is where the story deepens beyond the question of Proxima b alone, because Proxima Centauri b is not the only world we have found. In the years since that first announcement, the catalog of potentially habitable exoplanets has grown in ways that would have seemed impossible to an astronomer of the 20th century. The Kepler Space Telescope, launched in 2009, stared at a single patch of sky for years and found thousands of planets. Thousands, where before we had imagined maybe dozens. It revealed a galaxy so crowded with worlds that the emptiness between stars began to feel less empty. Among those thousands, worlds in habitable zones. World the right size. Worlds with the right temperatures. Worlds with names that sound like codes, because we haven't yet earned the right to name them the way we name the places we can touch. Kepler 452b, a world 60% larger than Earth, orbiting a sun-like star in a habitable zone, 1,400 light-years away. Nicknamed quietly Earth's cousin, a world that receives nearly the same amount of energy from its star as we receive from ours. A world that may have liquid water, a thick atmosphere, active volcanoes still building its surface from within. TRAPPIST, one, not a single world but a system. 7 planets orbiting a red dwarf 40 light-years from Earth, 3 of them in the habitable zone. 3 worlds orbiting the same dim star, each one a candidate. A system that made astronomers pause and stare at the data for hours, checking and rechecking, unable to quite believe what the numbers were saying. And beyond these, hundreds more, some too hot, some too cold, some too large, swayed in crushing atmospheres of hydrogen and helium, gas giants with no surface to stand on, some too small, their gravity insufficient to hold any atmosphere at all, but some are so close to right that the distance between them and Earth becomes almost a technicality. Almost, because light years are not a technicality. They are a wall made of time itself, and we are creatures of very little time. For light years to Proxima Centauri b, at the speed of our fastest spacecraft, the New Horizons probe, launched in 2006, the fastest object humanity has ever built. The journey would take 73,000 years. 73,000 years. Civilizations rise and fall in centuries. The oldest human writing is 5,000 years old. 73,000 years ago, our ancestors were painting animals on cave walls, wearing animal skins against the cold of an ice age, looking up at the same stars we look up at now and telling stories about them. The distance is not a number. It is a reckoning. And yet, we are not standing still. Breakthrough Starshot, The initiative, backed by some of the most ambitious minds in physics and engineering, proposes to send a fleet of tiny light-propelled probes, each one smaller than your hand, accelerating to 20% of the speed of light on beams of focused laser energy. At that speed, Proxima Centauri becomes a 20-year journey, not for humans, not yet, but for our instruments, for our eyes, for the first reconnaissance of another world. 20 years, the length of a childhood, the length of a career, the length of a war that changes everything. Those probes would send back pictures, chemical readings, the first direct look at another world sky, and we would know, finally actually know, whether the atmosphere of Proxima Centauri contains the signatures of habitability, whether there is oxygen, whether there is water vapor, whether there is something that should not be there unless something living put it there. The last possibility, the one that barely dares to be spoken aloud, is that the atmosphere of Proxima Centauri might not simply be survivable. It might be inhabited, not by anything we would recognize, not by cities or radio signals or lights visible from space, but by chemistry, by the slow biological transformation of a world's air, the way cyanobacteria transformed ours, silently, over billions of years, building the atmosphere that eventually allowed us to exist. Life, if it is anywhere else in this galaxy, is almost certainly not looking back at us. It is almost certainly not aware of us. It is almost certainly not asking whether we could breathe in its world. But it might be breathing in it. And that breath, that alien, unintentional, mindless exhalation of chemistry into the air of a world circling another star, will be the most important discovery in the entire history of our species. It would not simply tell us that life exists elsewhere. It would tell us that life is what the universe does. That life is not the anomaly. That the anomaly was ever thinking we were alone. Stand again at that edge, the one at the beginning of this story. You have traveled a long way since then, not in space, but in understanding. You have breathed the air of a world that took 3 billion years to build. You have looked at the surface of Mars and seen the memory of what might have been. You have stood at the terminator line of Proxima Centauri b, in imagination, in mathematics, in the closest thing we have to vision at 4 light-years distance, and felt the wind that might exist there, howling from the eternal day into the eternal night. And you have asked the question that our species has been building toward since the first human looked at the night sky and felt the vertigo of infinite space above them. Are we alone? But here is what that question actually means. Underneath the science and the mathematics and the telescope readings and the atmospheric models, underneath all of it, what that question is really asking is this: does this vastness have any meaning? We are small. We know that. We have known that since Copernicus moved us from the center of everything to a small rock orbiting an average star in 100 billion galaxies. We have known that since the Hubble Space Telescope photographed the ultra-deep field, that image of 10,000 galaxies in a patch of sky the size of a grain of sand held at arm's length. And we understood in our bones that the universe is not arranged around us. And yet we persist in the search, not because the science demands it. Science is indifferent to meaning. Science measures what is, not what it signifies. We persist in the search because something in us, something older than civilization, older than language, older than fire, needs to know whether the darkness is empty or full, whether we are a lonely accident in a silent universe, or whether we are one voice in a chorus, so vast we simply have not yet learned to hear it. The atmosphere of Proxima Centauri b is unknown. The atmosphere of Kepler 452b is unknown. The atmospheres of the TRAPPIST, one world, are being studied right now. Right now, as you read these words, as you breathe this air, by the James Webb Space Telescope, the most powerful humanity has ever aimed at the sky. It is looking for water vapor. It is looking for carbon dioxide, methane, ozone, the chemical fingerprints of worlds that might hold something alive. The data is coming, slowly, in the way that all important things come, not in flashes, but in the accumulation of small certainties, each one building on the last, until one day the picture is undeniable. We will know, perhaps not in this generation, perhaps not in the next, but we are closer than we have ever been, and the distance is shrinking faster than any telescope has shrunk it before. And when we know, when the first atmospheric reading comes back from a world orbiting another star and carries within it the unmistakable chemical signature of biology, when we sit in the silence of that discovery and understand what it means. It will not feel like a scientific result. It will feel like an answer to a prayer that no theology was ever quite specific enough to ask. It will feel like the moment the cave painting is finished, the moment the hand pulls back from the wall, and the animal depicted there is no longer just pigment, but something that will outlast the painter by 40,000 years. It will feel like the first breath a newborn draws, that gasp, that violence of entry into a world that had no idea it was waiting. We found a second Earth. Perhaps, possibly, provisionally. The word second implies comparison, and comparison implies that we understand the first one, and we are still learning that, still mapping the microbiome of our own oceans, still discovering species in the deep forests, still watching our own atmosphere change in ways we set in motion without fully understanding what we were doing. We are searching for a second Earth while we are still in the middle of understanding the first one. There is no irony in that. There is only truth, because that is what human beings do. We reach forward while we are still arriving. We look outward while we are still learning to look inward. We build ships for oceans we have not yet named while we are still standing on the shore of the ocean we were born beside. It is not recklessness. It is not arrogance. It is the thing that has kept us alive and moving forward through every darkness this species has ever entered. The question of whether we could breathe the air Proxima Centauri B is, on one level, a scientific question about atmospheric pressure and molecular composition, and magnetic field strength and stellar flare frequency. But on another level, the level that actually matters, the level that reaches down into whatever it is that makes human beings human, is the oldest question there is there a place for us in this universe? Not just a hospitable planet, not just a breathable atmosphere, but a place. A sense that the cosmos is not indifferent to us, that the laws of physics that built atoms and stars and planets, and eventually eyes and hearts, and particular ache of wondering, that those laws bent, somewhere in their unfolding, in a direction that had us in mind. We do not know the answer. We are looking, and the looking itself, the reaching, the instruments we have built, the mathematics we have developed, the collaboration of thousands of minds across generations, the looking itself is the most beautiful thing our species has ever done, more beautiful than any single discovery, more profound than any single answer, because it means that the universe made something that looks back at it and asks why, and in all the cold and silence between stars that, perhaps, is miracle enough. The stars are out tonight. They are always out. We simply do not always look. Look up, somewhere in that darkness, past the moon, past Mars, past the edge of the solar system, and the long cold silence beyond it, a planet turns. It has been turning longer than we have existed to imagine it. It knows nothing of us. It does not wait for us. But we are coming, slowly, blindly, beautifully. The way life has always come, we are moving toward it. And somewhere in the questions we carry with us, in the telescopes we have aimed at its star, in the mathematics we have built to describe its orbit, in the simple, impossible human act of looking at a single point of light in the sky and asking what is there, perhaps that is already kind of a rival. This universe is 400 billion stars wide in this galaxy alone. It has been building for 13.8 billion years. And somewhere in all of that, on a small blue world, in a thin shell of air that took 3 billion years to make, something looked up. Keep looking.